So if we take a look, today we are Wednesday, final exam review. So again, I'm going to open it up to questions, maybe work through some of the other problems in there. And then tomorrow you've got the last progress check. This progress check is going to check two things to basically make sure that you can use what's called the lockdown browser of the AP classroom board. If you've not used that before, let's show you real quick how to do that. And then on Friday, final exam review, and then don't see you on Monday, and then on Tuesday, first thing, you've got that final. Finishing strong. All right. That's not what I want. Sometimes this thing messes up whenever I unplug it. Let's try this again. Hey, there we go. So if we take a look, if you have a separate computer or whatnot, I don't know if you do, but if you have one, maybe you can pull your Chromebook out and make sure that you can get this to function. But all I've done is set up the Chromebook by pressing the button right here on the side. So this is the login screen. Now, instead of signing into your Chromebook, this is kind of anti-intuitive. You're going to sign into one of the apps that should be logged onto there. It's called the College Board app. And when you click that, that will open up their browser. This is what, if we have to take tests online, this is where you'll go. So whenever you sign into here, it will open up your My Classroom, and then you'll be able to access that on there. Now, the reason you have to do it tomorrow is because I chose a few secured questions, and they only allow their secured questions to go through this browser. So please make sure you use that. Again, all you're going to do is click on this on the side. And then press that down there. And here's the weird thing about it. It won't let you actually exit this browser unless you restart the device. So you can try to exit out. So then you've got to basically hold that down until power off comes up and click on that. So a little side button to get it to come on. And then instead of logging in, like I said, it's kind of anti-intuitive. Like you would think like they would want you to be logged in so you're more secure, but that's not the idea. When you log in through the Chromebook log, basically that gives you access to the internet. And this is supposed to be used to block that. Obviously you guys have phones and everything like that, but you know, this is what they want. It's funny. It's like, you've chosen select questions, and in order to, or in an attempt to prevent printing of these, and I'm just like, obviously, you know, you can't take a screenshot with shot with this, but you know, I mean, how many cameras are in your room right now, right? All right, so that's that. What that means is once you log on to the AP Classroom app through there, then you'll go to progress checks or assignments. It's actually assigned right now on there. So I mean, you can check that out. But basically, this is just a semester progress check. It's a I think it's assigned on there. But basically checking you throughout the semester. That's because I'm not a student, probably. Another thing is, I think that 2 of you need to do the unit 4 still. I went through and graded those last night. I was going to discuss some of the questions on there today, but we still need 2 people to get it. So if you could get that by the end of the day, it should be open still for you. I noticed one of you guys had started it, but somebody still hasn't started it. So if you could get there and get unit 4 done, the unit 4 progress check, that would be great. All right. Typing in Mr. Verbrugge's old test, I did realize something. What I did, instead of keeping like formula things, questions that were multiple choice, I changed them to formula questions. So basically what that means is that it basically formulates a different question for everybody. I thought that was a decent way to show test security or whatnot. So just keep that in mind. I think I told somebody that it was, it's funny, it's Mr. Verbrugge for you, but it was 79 multiple choice questions, 79. And I'm sitting here thinking, well, he would tell people it's 80 questions. There's 79 multiple choice and 1 essay. So I'm assuming that's what he did. But I'm going to end up, I think, probably bringing it down closer to 50 to 60. It's not all multiple choice. So basically any of the math problems, you may, have to type in the number. With that, when you have to type in the number, Canvas is not smart enough to detect significant digits. So basically, I'll try to tell you the unit place that you round to, but usually there's some type of percentage in there that you can have some play with. Like if you type at least 1 decimal place or something like that, you're usually good with it. Questions about final exam or that lockdown browser?
So we're not having a Zoom tomorrow?
Louder.
We're not having a Zoom tomorrow?
Nope. I will be on here just to make sure that people can get through the lockdown browser if you have questions or something like that, or if you need me to show you or something. But I mean, you don't have to show up. I don't want to, yeah. Currently, I mean, we have 3 days, Wednesday, Thursday, Friday. An hour of the, if you watch that video, that's an hour right there. And I'm assuming it's going to take you at least maybe an hour and a half to get through the progress. It's about 20, I think it's 30 questions. They're all multiple choice this time. There is no free response. But, I want to make sure that you guys have time. I mean, this is the week before finals, or, what they call dead week. And I'm trying to minimize the time that you have to spend outside. So, yep, that's true, Hayden. But if you want to join me, you're more than welcome. We'll have a little breakfast together. All right, without further ado, are there any questions as you went through here? I know that that people are working through these because I get, emails and stuff like that, but usually those are quick changes or quick answers. I did notice that he did not teach you energy, the energy shells, it looks like, because he has this crossed out. Just keep in mind, like, the first principal energy level can also be called the first principal energy shell. Second principal energy level can be called the second principal energy shell. If you're reading something, that can come up.
Could you go over 30 through 32?
30 through 32. Yep. So state the values of, and I'm going to zoom in on this. State the values of N and L for electrons with the following labels. So N is equal to your principal energy level. Or your PEL, sometimes it's called. L is equal to your sublevel. So the sublevels are S, P, D, and F, and they continue past this, but this is all we need for all the elements on our periodic table. So L is a number that starts at 0. For S, it's 0. For P, it's 1. For D, it's 2. For F, it's 3. N starts at 1, and for our periodic table, it goes all the way up to 7. So if we take a look, you remember that the N is equal to the number of sublevels. So the first principal energy level has one sublevel, S. So that would be 1, 0 would be the 1s sublevel. N equaling 1 and L equaling 1 would not work. But N equaling 2, we have 2, 0 for the 2s and 2, 1 for the 2p. So if we take a look here, for 4f, this 4, N equals 4. And L, always start at 0, S, P, D, F. L equals 3. And then after that, you would have your L sub M, and it's based off of this 3. So L sub M describes the orbitals. So F has 7 orbitals. Right? So basically we start at negative L. And we go up to positive L. So M sub L has a range of negative L to positive L. And basically that describes each of those orbitals. That's what that next letter does. It doesn't it's not asking you for this, but that's what the next letter would do. So for 31, N equals 2, L equals 0. There's only one L of M for the S because it's 0. There's no positive and negative 0. So the 2s orbital would basically be that 0 if we looked at the L of M. 2p, N equals 2, L equals 1. And then if we look at that, P has 3 orbitals, negative 1, 0, 1. Now there is one more, there's the 4th digit. So let's say we have 1, 2, 3. So right here we have all unpaired electrons, right? The maximum for P is 3 unpaired electrons because there's only 3 orbitals. The maximum for F would be 7 unpaired electrons, right? So here we have 2, 1, and let's pick that last unpaired electron. M of L would, L of M would equal, I'm sorry, M of L, not L of M. Really. M of L would equal 1 because it's in that last one. The last one is the magnetic spin. Any arrow that is going up has a positive 1/2 charge. If we were to come back and fill and talk about a different one of these electrons, then it would be a negative 1/2 charge. But this one right here that's going up, the spin is equal to plus 1/2.
So the last two numbers, that's M of L and M of S, right?
Yeah. Yeah, I said L of M at the beginning because I don't know, morning brain, but it's M of L. Sorry about that.
Could you go over 20, please?
20. What is the empirical and molecular formula of a compound consisting of 43.6% P and 56.4% O? So let me tell you a little bit about, I got this buddy who goes, let me tell you something. He always points his finger at me, but let me tell you guys, and he says it very aggressive, but let me tell you a little thing about empirical formula. If you want an empirical formula, remember it's the most reduced. So at its lowest, it is a ratio, and it's the lowest whole number ratio of moles, not ration ratio of the moles. So the key here is you've got to know how to make a ratio. To make a ratio, you divide by the smallest number of moles. We divide by the smallest number of moles so we can get a 1 to something. If we get a 1 to a fraction, we've got to make it a whole number ratio. Right? Well, if all we're doing is dividing by the smallest number of moles and making a whole number ratio of moles, we've got to have moles. Now, in this case, we have percent, and this is percent by mass. So basically, anytime you've got to get an empirical formula, you've got to, number one, find moles. If you know all the different ways to do that, that's a bonus. If you don't, that's a weakness. So if we take a look, percent by mass is actually equal to the grams. So if we have 43.6% P and 56.4% O, these are going to add up to 100. That means out of 100 grams substance, 43.6 grams is P and 56.4 grams is O. We then, as I said, find the moles. If they said grams here, then you would just say, okay, grams to moles. If they said atoms, I would go atoms to moles. I would. They're shortcuts, but if you just got to find the moles and divide by the smallest number of moles, just get to moles. Don't try to memorize other little things. So every 1 mole of P is 30.97. And every 1 mole of O is 16. A key thing to remember is that this is not diatomic because we don't know how many O's there are because it's paired up with P, but we know for 56% of the mass of this 100 grams is O. And that's the molar mass for O, so we don't try to think about diatomic stuff. 43.6 divided by 30.97. Oh, it's actually not working today. Got to use my finger in a calculator, like. $30.97. So 46.3 divided by 30.97. It gives us 1.4078. And I usually go out as many as I can for here because I know I'm just trying to find the mole ratio. So I want something that, whenever I divide it by itself, it's 1. And whenever I divide something else by it, it's a nice number. The more decimal places you out, the more likely that's going to happen. 46.4 divided by 16, 3.525. So out of these two, that's how many moles of P we have for a 100 gram sample. That's how many moles of O we have. Out of these two, we want to make a ratio. Well, if we divide by the lowest one, we get a P1 to O something, right? So we take that 3.525, we're going to divide that by 1.4078, and we get 2.5. So 1P to 2.50. Remember, I did say that this needs to be a whole number ratio of moles. So that means 1 to 2.5 won't work. So instead of that, I multiply each of these by 2, and I get P2O5. So that is the empirical formula. That's the most reduced. Now it wants us to find the molecular formula, and it's given us the molecular mass. Well, we know that to find the molecular formula of this, basically, that molecular formula has been divided by some factor to make that 2:5 ratio. So whatever the molecular formula is, it's P2X O 5X. We just need to find that X. Well, if we know the mass of this, 284.0, and we know the mass of this, well, the mass of this to the mass of this is going, divided by the mass of this, is going to be that X. So 2 times 30.97 plus 5 times 16.
It's 141.94.
So there we go. It looks like it's going to be 2, right? 284 divided by 141.94.
It's about 2.00008.
So we need to multiply each of these by 2 because that X is now 2. So that's P4O10. Is that good? Any other questions through here? This back page back here, I'm just going to go through a few things that I saw then in the progress checks. And the laboratories. So for this graph of pH to milliliters of, most of the time it's like a base or whatever you're titrating. I think in the progress check where you guys were to draw a line, this was like 20 milliliters. And basically the pH here, they gave you the drawing and they said, here is the pH of this one, and you were basically supposed to say where was the equivalent point. And I'm just thinking that for some of you guys' standardization labs, I think you just quit too early because you started to get to here, but then you know, you never got back up to here. I think only about 25% of the graphs that I saw actually got up to this point. So that right there would be where you have that equivalence point, where you have that kind of, now yours may have been smaller than that or something like that, but that was the idea. So then they said if this was with a 0.10 molar HCl, and this is NaOH, and I don't remember what the molarity of it is. Maybe it was 0.2 or something like that. But then they said they wanted you to draw 0. They wanted you to draw a 0.20 molar HCl. A lot of people actually did that here. They put it before. But this is a higher concentration of HCl. It's twice the concentration. And a lot of you even drew that whenever you drew the circles of the H's and the Cl's. You doubled the amounts that you had from before. So that means that this NaOH, it's going to take twice the value of that NaOH. So we're going to be looking at 40. What else would we know about its pH? Because they gave us this first graph. Would the pH be higher or lower for double the concentration of HCl? It's HCl and acid. Yeah, it's going to be lower. So and this is just AP like testing things. It's going to be lower. So what they wanted was they wanted something lower than 1 for the pH, and they wanted that curve to go at 40 because it would take twice the amount of NaOH to pair up with these moles of H's. It would take twice the amount of OH negative to neutralize that. So it'd take 40 milliliters versus the 20 milliliters it did to neutralize this guy. So just keep that in mind. Like a lot of people said, well, this is double the concentration. I think you were thinking rates in your mind. So they were like, double the it's going to happen faster. That's not true. This is that standardization laboratory. If it takes this much to do this, it takes twice as much to do twice the concentration. The other, actually, if you guys have questions, I'm just rehashing stuff that I saw from that. So if you guys have any more questions over the final exam review pack, by all means, this is your time, but I want to kind of rehash some review stuff too if you don't. All right. Dang it, I should have had an example for this. Let's just take, that's kind of a garbage one, but it's fine. Some of you guys are having issues with the net ionic equations. So this is a simple net. What did I put an arrow there for? I am so low on whiteout. I'm gonna have to make too many mistakes. So what type of reaction is this? Let's just do like a quick review. Just yell it out or type it in. I'll even open up the things if you don't want to talk to us this early in the morning.
Double replacement.
Double displacement, good. Or double replacement is fine too. AG and NA are switching places. It is balanced. I'm not going to force you to look up that solubility chart, but hopefully you would have been able to get that. Now, the whole idea with a net ionic equation is anything that is aqueous on both sides is not going to be part of the reaction. So to break this down into what we call the the ionic equation, basically you would take everything that's aqueous and break it down. Now, this is kind of a trick because in reality, it's not just that it's aqueous, it's that it readily dissociates. I'll get to that in a second because that might have been a little deceitful on my part, if you know what I'm talking about. Since this is solid, it stays together. Now, if I had any coefficients in front of these, those would also break down into here. For example, let's take barium chloride. Let's take magnesium chloride. And you said 2Cl. That means I would have 1 magnesium 2 plus aqueous and 2 Cl negative aqueous. Because they are dissociated. That means that everything has been pulled apart if they are readily soluble. Now, down here, whenever I look at both sides, I look at Ag, okay, it's aqueous over here, but it's trapped in here. So that's part of the reaction. NO3 is the same on both sides. It's aqueous, so that is not part of the reaction. Na, not part of the reaction. Cl negative. That would be my net ionic equation. Now, in this last progress check, they were a little bit sneaky. They used HF, and they called it aqueous. What is the problem with HF? Tell me a little bit about it. What type of chemical is it?
An acid.
There we go. It's an acid. Now, we know two types of acids. We know that there are strong acids, which dissociate completely, And we know that there are weak acids which do not dissociate, less than 4%. So the fact that we know that these are readily soluble and they break down, we know that this does not readily dissociate. All dissociation means is it breaks into its ion forms, right? The two separate ions. We know that this does not readily do that. So whenever we put this in to an ionic equation, we keep it together. And they then, after they did this one, that was kind of funny, they used NH3. What's that chemical? We know NH4 is ammonium. So what do you think this is? You guys know this, you have to, at least one of you. You're gonna make me give it to her, huh?
I didn't quite hear the question.
What is this chemical called? If this is ammonium, this is NH3, it's in glass cleaner, right? Hardest question of the day is NH3, what is it?
It's ammonia, right?
Yeah, it's ammonia, yeah. Ammonia. So again, it was like 2 questions later, it was kind of funny. And I don't know if they show you the answers to the questions or whatnot down at the bottom as you're taking it. But this one right here, well, if you don't know, this is a base. Well, we know, hopefully we know the strong bases. They are the alkali metal bases, as well as calcium is also considered, and magnesium, sometimes strong base. So this is just as this was a weak acid, this was a weak base. And I think it was kind of sneaky of them to put that into the reactions chapter, because we talk about this dissociation a little bit more when we get into equilibrium of acids and bases next semester. So I thought that was pretty sneaky, but it's the same thing. They only have about 4% dissociation as well, or less than 4%. If that were NaOH or something like that, yeah, you would break that apart. But NH3 and HF, since they are weak acids and weak bases, they don't, the term is actually interesting, it's appreciably. They don't appreciably dissociate, meaning they don't do it that much. Last thing, unless again, if you've come up with a question, there seems to be a lot of confusion with what is known as hydrogen bonding. And I'm picking these because these are all big topics. Hydrogen bonding, let's just do it with water. So basically the high electronegativity here gives this, the head of this water molecule, or the oxygen of this water molecule, it pulls these electrons in and it gives this a partial negative charge. That gives these guys down here a partial positive charge. Now, if I have another water molecule, I saw some people drawing or accepting answers where hydrogen bonding was occurring between 2 hydrogens. That's not what hydrogen bonding is. Hydrogen bonding doesn't occur between 2 hydrogens. It wouldn't occur between 2 hydrogens because they're both positively charged. Hydrogen bonding is called hydrogen bonding because very high electronegative chemicals, NOF, NOF, and I believe Cl as well, but NOF and these guys right here, I have to check that Cl, it's been a while. But these guys right here, you know that these guys can perform the hydrogen bonding. Let's see, 3.0, 3.0. I'm saying yeah. But those guys right there can perform the hydrogen bonding, which means that they're pulling those electrons far enough away, the electrons in the bond of this hydrogen oxygen bond, they're pulling them far enough away from the hydrogen that they're getting this charge. So the positive and positive are not going to attract. It's the negative and the positive. So that's where that hydrogen bonding is going to occur. It's not between the hydrogen and hydrogen. Another thing I saw was we had a calcium or a magnesium or something like that, something with a 2+. And they had a drawing and they wanted you to kind of describe how, what makes this drawing work. So they put a calcium ion in the middle. Or maybe it was a chloride, negative ion. Anyway, it may have been that. But either way we do this, they wanted you to basically draw how you would see this. Well, again, that partial negative is not going to be close to that negative here. And that positive is not going to be close to here. So basically, they showed you how ion dipole interaction can work. And basically, we had, the oxygen filling in around that positive one, and then the hydrogens filling in. I don't know why I'm writing them as O's. I was just doing like a particle diagram or something like that. But basically, these hydrogens filling around all around this one, and the oxygens filling around this one. One of the biggest things that you can do whenever you're looking at these questions is to look at charges and stuff like that. Charges and sizes. Just the fact that this is bigger because of being negative and stuff like that comes up a lot, and it's smaller because we've lost electrons. Those are big things. Any other questions? No. All right, those were the big points I wanted to make. If you do have trouble getting on to the lockdown browser tomorrow, please come in. We'll try to figure it out. Other than that, Friday, if you have questions, hopefully you look over the exam final review, come in with questions. I got a question yesterday like, hey, Mr. Jackson, do we have to take this final if we have an A? Yes, this is not one of those classes that we're exempting the final for having an A, unfortunately. Talking to the department head, didn't think it was a good idea for this class. That's the deal. Hopefully you guys are getting out of some of your other finals. I heard this discouraging news that from one student that said, no, all my teachers, and I'm like, it's not that. Some classes it leans to, because there were, some students that really worked hard, and then the rest of the students were like, yeah, I'm not doing that, So it's a reward system, and it's not mainly meant for the higher level classes. It's meant as a reward system for the medium, the college prep classes and stuff like that. Is like, because the grade differential in those classes is kind of incredible to look at sometimes. It may not be apparent to you guys, but you have to imagine that there are some kids that ghosted their teacher, and they, they're not there anymore, and the teacher's like, what do I do? Any questions before I get off of here then? All right, please, if you need to do that Unit 4 progress check, get it done. In my mind right now, I've got all the grades up to date. If that is not true with you, please contact me somehow. Other than that, get out of here. Have a great day, and I'll see you Friday if everything goes well.
Thank you.
Thank you.
Actually, Mr. Jackson, I do have a question about grades.